Hi, so we're almost finished. This will be the second to last video on this paper. So rearrange the following formula to make k the subject. So changing the subject is essentially solving an equation, but instead doing it a bit more generally. So a lot of people would feel confident solving something like 5 equals 3k plus 2, because they would minus 2 on both sides, and they would have 3 equals 3k, and then k equaling 1. But because there's a second variable, people find this quite difficult for some reason. So we're just going to proceed exactly like we normally would. So the whole goal of making k the subject is getting it to k equals. So I'm going to minus 2 on both sides. So I get that p minus 2 on this side is equal to 3k. And now I want to get k on its own, so I divide by 3. So k is equal to p minus 2 over 3. And that's it. Does the midpoint of the straight line joining points 315 and 719 lie on the locus y equals 3x plus 2? Okay, so people find these exceptionally difficult, and they're really not too bad as long as you know what you're doing. I suppose the same goes for everything. So let's find the midpoint of this line first of all. So the midpoint of this line is, we just find the middle number for each of the ordinates separately. So what is the middle number of 3 and 7? It is 5. What is the middle number of 15 and 19? It is 17. So this is the point we're using. So it asks, does the midpoint of the straight line, so does this point lie on the line 3x plus 2? So y equals 3x plus 2 is a locus, as I mentioned in a previous video in this playlist. All it is it's a relationship between the x and y ordinate. So what this is saying is the y coordinate 3 times the x coordinate plus 2? Yes, it is, but it says to show all of our working, so let's do that. So y equals 3x plus 2, so let x equal 5. So y equals 3 times x plus 2, so 3 times 5 plus 2, which is 15, plus 2, which is 17. So y equals 17, so yes, it is. So essentially, is the y value 3 times the x value plus 2? Yes, it is. So moving on, express 0.0058 in standard form. So I want the point to be there. So it is 1, 2, 3. So it is 5. It becomes 5.8, and then that is times 10 to the power of minus 3, because it's a small number. I know that it's negative. It's a negative power. So the point of standard form is this number here needs to be between 1 and 10. It's allowed to be 1, but it's not allowed to be 10. So what I do is I look at this number and think, where does the decimal point need to be to make this number between 1 and 10? So it is here, and then the number of jumps was 3, so I go negative 3 because it's a small number, and that number then becomes 5.8. Okay, calculate the value of 1.4 times 10 to the 9 divided by 2 times 10 to the 3. Okay, so we just do these separately. So this essentially is 1.4 divided by 2 times by 10 to the 9 divided by 10 to the 3. We just do them separately. We just do the divide separately. So 1.4 divided by 2, 10 to the 9 divided by 10 to the 3. So 1.4 divided by 2, that's the same as 14 over 20, which is 7 over 10, which is 0.7. So this is 0.7, and then 10 to the 9 divided by 10 to the 3 is 10 to the 6. So we have here that we have to give our answer in standard form, so we need to index shift this because this is not between 1 and 10. So timesing this by 10, this is 7, and we need to divide this by 10 to compensate. So dividing this by 10, it is 7 times 10 to the 5. You could also turn these into ordinary numbers and do the division that way, but using standard form is much simpler. So a group of people have put their names forward to carry the Welsh flag at a sporting event. Each person lives in North, Mid or South Wales. One person from the group has been chosen at random. The probability of choosing a person who lives in North Wales is 0.3. The probability of choosing a person who lives in Mid Wales is 0.25. The probability of choosing a person who is under 18 years old is 0.2. People's ages are independent of where they live. So we use the first axiom of probability to complete this. So for each event, the probability of all the events possible must sum to 1. So I know that this is 0.3, this is 0.25, so this one here must make these three add to 1. And it disappoints me a little bit to this day that I see people seeing this 3 as 3%. This 3 is not 3, it is 30%. So this is 0.30 plus 0.25, that is 0.55. So to make this 1, this needs to be 0.45. And so we are told in the question, the probability of choosing someone who is under 18 is 0.2 years old. So again, by the same axiom of probability, if we've chosen 0.2 for this, or 0.20 technically, this must be 0.8. And because they are independent, the same will repeat for all of these branches. And then part B, what is the probability of choosing someone who lives in South Wales and is under 18 years old? So the probability of picking someone who lives in South Wales is 0.45. And so probability of picking someone who is under 18 on this branch is 0.2. So let's find the probability of doing it. And the reason we multiply these is because these are independent events. So we're going to do 0.45 times 2. So this is 2 after the point, and this is 1 after the point. So what is 45 times 2? It is 90. And we want 90 to be 3 after the point. So it is 0.090. So this makes our answer equal to 0.09. Because this 0 on the end is a bit redundant. So the answer is 0.99. So it is 0.09, so that is 9%.